Hi students, in the last video we have seen what conic sections are, then I gave analytic definition of a conic section, then we derived general equation of the conic section, then we mainly focused on parabola, we looked at various standard form equations for the parabola, also equations of the parabola whose axis parallel to coordinate axis. In this video, first I am going to talk about position of a point in the plane with respect to given parabola. Then I am going to do problems. Now we are going to talk about position of a point with respect to given parabola. First of all, a parabola divides plane into two disjoint parts. One containing the focus is called interior of the parabola. We can also call inside the parabola. Other is called exterior of the parabola. We can also call outside the parabola. Question is, for a given point and the parabola, is there a way to decide whether a point inside the parabola or outside the parabola? Answer is yes. Next I am going to do the result which will help us to solve this problem. I am going to use some notation for the result. So let me introduce some notation first. Okay. Here is the notation. In the following results, I am going to use the following notations. We will use S to denote the expression y square minus 4ax, S1 to denote the expression y1 minus 2a of x plus x1, S1 to denote the expression y1 y2 minus 2a of x1 plus x2, and S11 to denote the expression y1 square minus 4a x1. Of course, S22 will denote the expression y2 square minus 4a x2. So most of the results that we will prove for the parabola, we will be using standard equation of the parabola y square equal to 4ax. Okay. Any result that we prove for standard equation of the parabola, which is in terms of these notations, will also true for general equation of the parabola. In that case, you should know what S means. S may be general second degree equation like this: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Of course, here ab minus h square must be 0 if it represents parabola. Fine. In this case, S1 will denote the expression axx1 plus h of xy1 plus x1y plus byy1 plus g of x plus x1 plus f of y plus y1 plus c equal to 0. And S12 will denote a x1 x2 h of x1 y2 plus x2 y1 plus b y1 y2 plus g of x1 plus x2 plus f of y1 plus y2 plus c equal to 0. And of course, S11 will be a x1 square plus 2h x1 y1 plus b y1 square plus 2gx1 plus 2fy1 plus c equal to 0. Okay. In terms of these notations, those results can be generalized. Okay, fine. Let us consider the parabola y square equal to 4ax and the point x1 y1 in the plane. Okay, this point anywhere in the plane. I'm not saying this point on the parabola. This x1 y1 is any point in the plane. Okay, so this point x1 y1 could be exterior of the parabola, or it could be interior of the parabola, or it could be on the parabola. So if point P x1 y1 exterior to the parabola, then it could be something like this. Here is the point x1 y1 exterior of the parabola. If it is inside the parabola, then the point could be something like this. Here is the point x1 y1. If it is on the parabola, it could be something like this. Here is the point P x1 y1. It's on the parabola. Okay, fine. Here, so if P is exterior to the parabola, y square equal to 4x. Now what you can do in this case, we can draw the perpendicular onto axis of the parabola. This is the PM, which is perpendicular. The foot of the perpendicular we are calling M. So it's going to be x1 comma 0. Okay, fine. Now, so this PM meets the parabola y square equal to 4ax at a point, let us say Q. Okay, so this is the point Q. So whose coordinates are going to be x1 comma 2 root ax1, because since this is a point on the parabola, okay, so since x coordinate is anyway x1, so y coordinate must be 2 root ax1. Fine. So it's pretty clear that from this figure we can observe that PM is bigger than QM. This PM is bigger than QM. Okay, when P lies exterior to the parabola, what is happening here? This PM is bigger than QM. Fine. In this case, here is a P inside the parabola. So we draw the perpendicular onto axis of the parabola. So the foot of the perpendicular is M. So whose coordinates are x1 comma 0. In this case, we extend this PM segment so that it meets the parabola at Q. So here again, the Q coordinate is going to be x1 comma 2 root ax1. Okay. In this case, you can see that this PM less than QM. Here QM is bigger than PM, right? Fine. Next, if P is point on the parabola, again here we are drawing perpendicular from P to axis of the parabola. So the foot of the perpendicular M, whose coordinates x1 0. The intersection of this PM and the parabola y square equal to 4x going to be the P itself, that we are calling Q. Okay, so here P and Q are same. Okay, so here we can see that the PM equal to QM. In this case, if P is the point on the parabola, so what we have, this PM equal to QM. Fine. From these graphs, we can observe the following things. P lies exterior of the parabola if and only if this PM greater than QM. Okay, so here what is PM? The PM, the height going to be y1. Okay, and what is QM? This QM height going to be 2 root ax1. Okay, so P lies exterior of the parabola if and only if this y1 greater than 2 root ax1. If you take a square both sides, if and only if we can say y1 square greater than 4ax1. Here this one we can write like y1 square minus 4ax1 positive. So this is equivalent to saying that S11 positive. So P lies exterior of the parabola if and only if S11 positive. Okay. Next, P lies interior of the parabola if and only if PM less than QM. In this case, what is PM? PM is this one y1, QM again, this height is 2 root ax1. So if and only if y1 less than 2 root ax1, this is equivalent to y1 square less than 4ax1, and this is equivalent to saying that S11 negative. Okay, fine. So P lies interior of the parabola if and only if S11 negative. Next, P lies on the parabola if and only if PM equal to QM. Okay, so what is PM here? This PM is Y1. Also same thing, you can also say 2 root AX1. So that's why here if and only if y1 equal to 2 root ax1, this is equivalent to y1 square equal to 4ax1, which is equivalent to saying that s11 equal to 0. So P lies on the parabola if and only if s11 equal to 0. Okay, this is how we can decide whether a point lies on the parabola or exterior to the parabola or interior to the parabola. So just looking at the quantity S11, if just look at this S11, if it is a positive, the point is exterior to the parabola. If it is negative, the point is interior to the parabola. If it is equal to 0, then point is on the parabola. Okay. This result is true for general parabola, not just for y square equal to 4x. Okay. For simplicity, we are just working with a standard equation of the parabola, that is y square equal to 4x. Okay. Let me do one example here. So let us take one parabola y square equal to 6x. Okay. So that means here s is what? Y square minus 6x. Okay. If you look at the point 6 comma minus 6, what will be? That means this is x1 y1, our point. Okay. So what will be s11? S11 will be minus 6 square minus 6 times 6. This is 0. So the 6 comma 6 point on the parabola. Okay, 6 comma minus 6 is point on the parabola y square equal to 6x. For example, if you take the point x1 y1 to be 0 comma 1, okay, then our s11 going to be 1 square minus 6 times 0, that is 1, which is positive. So this 0 comma 1 point lies outside the parabola. Okay, so this 0 comma 1 point exterior. So this 0 comma 1 is, so this point 0 comma 1 is exterior to the parabola y square equal to 6x. If you take your point to be 2 comma 3, let's see what is S11. S11 going to be 3 square minus 6 into 2. Okay, so which is going to be minus 3. Okay, minus 3 negative. So this point 2 comma 3 lies interior. So this point 2 comma 3 lies interior of the parabola. So this point 2 comma 3 lies inside the parabola. Fine. So this is how you can easily decide whether a point lies on the parabola or interior of the parabola or exterior of the parabola. Okay. Fine. Okay. Now let us do problems. The problem 1. Find the coordinates of the vertex and focus and the equations of the directrix and axis of the following parabolas. The first one is y square equal to 16x. This is one of the standard equation of the parabola. If you compare this one with a y square equal to 4ax, then we have a 4a equal to 16. That implies a equal to 4. Now we can answer everything. The vertex of this standard parabola going to be origin 0, 0, and the focus is going to be what? A comma 0. So here a equal to 4, so it should be 4 comma 0. And the directrix for this standard equation is, we know, x plus a equal to 0. That means it should be x plus 4 equal to 0. and the axis of this standard equation is x-axis. That means equation is y equal to 0. Let me draw a rough picture here. Here is the focus 4, 0. This is the directrix x plus 4 equal to 0, and this is the vertex 0, 0, and this parabola open right side like this. Okay, fine. Okay, now let me do the second one. Now let us find out vertex, focus and equations of directrix and axis for x square equal to minus 4y. Okay, again if you compare with one of the standard equation that we have x square equal to minus 4ay, then we have a equal to 1. Now we can answer everything. Again, vertex is origin. Focus is going to be, for this standard equation, 0 comma minus a. So it should be 0 comma minus 1. And directrix equation for this standard equation is y minus a equal to 0. So it should be y minus 1 equal to 0. And axis of this standard equation is y-axis, whose equation is x equal to 0. Let me draw rough picture here. So here is the vertex 0, 0, and the focus is yes 0 comma minus 1. Okay, so this is open downward, and let me draw directrix here, y minus 1 equal to 0. This is the line parallel to x-axis, y minus 1 equal to 0, and the parabola open downward like this. Okay, so fine. Okay, now let us answer this. First of all, this equation 3x square minus 9x plus 5y minus 2 equal 0, I can write like this. Y equal to minus 3 by 5 x square plus 9 by 5 x plus 2 by 5. So this one look like y equal to ax square plus bx plus c, where a is negative. So since y equal to some quadratic expression of x, we know that this is a parabola whose axis parallel to y-axis. Since a negative, it opened downwards, right? So this equation must be in this form. So this equation must be in this form. X minus h whole square equal to minus 4a times y minus k. Okay. If we can write equation in this form, then we can immediately answer all these questions: vertex, focus, directrix, axis, right? So we need to figure out this HKA. So we want to be able to write this equation in this form: x minus h whole square equal to minus 4a times y minus k. So whatever choice of HKA. Okay. So okay, let me write down this 3x square minus 9x plus 5y minus 2 equal to 0. Okay, now so let me take 3 common, then I will write x square minus 3x equal to minus 5y plus 2. If I bring 3 this side, then x square, this 3x I want to write like a 2 times 3 by 2x equal to minus 5 by 3y plus 2 by 3. Here left hand side I want a square, so here I want to be able to complete square. For that I want to add and subtract this 9 by 4. Let me add and subtract 9 by 4. Okay, so that this part will complete square. Okay, now we can write x minus 3 by 2 whole square. If I take this minus 9 by 4 right side, then we have a minus 5 by 3y plus 2 by 3 plus 9 by 4. Okay, now x minus 3 by 2 whole square equal to here minus 5 by 3y, this one 8 plus 27 by 12, so this will be equal to what, 35 by 12. Okay, so if I take this minus 5 by 3 common, then y minus, then we have a 3 by 5 times 35 by 12. So here 3 and 12 we got a 4 here, 5 and 35 we got a 7 here. So we have here minus 5 by 3 times y minus 7 by 4. Okay, so x minus 3 by 2 whole square equal to, we got this. So I want to write like this, x minus h whole square equal to minus 4a times y minus k. Okay, for some choice of a, h, k. I think h and k is clear, so let me write like this, x minus 3 by 2 whole square equal to here minus 4 times 5 by 12. So this 5 by 3 I am writing 4 times 5 by 12, same thing. Okay, now y minus 7 by 4. Okay, now here the choice of h comma k is what, 3 by 2 comma 7 by 4. So h is 3 by 2, k is 7 by 4, and choice of a going to be 5 by 12. Okay, now we can answer the vertex. Now what is the vertex? Vertex is h comma k, right? So h comma k choice is 3 by 2 comma 7 by 4. So h equal to 3 by 2, k equal to 7 by 4. And focus, what is focus for this one? It's going to be h comma k minus a. Okay, so it's going to be 3 by 2 comma 7 by 4. What is a here? 5 by 12. So 7 by 4 minus 5 by 12, it's going to be 3 by 2, and this one going to be this 7 by 4 minus 5 by 12 gets simplified to 21 minus 5 by 12, it's going to be 16 by 12, that will be 4 by 3. Okay, so 3 by 2 comma 4 by 3, that's the focus. Okay, now the directrix equation is, what will be the directrix? That is going to be y minus k minus a equal to 0. So y, what is k we got? 7 by 4 minus a, so which is 5 by 12. So now we have y equal to, so 7 by 4 plus 5 by 12 going to be 21 plus 5 by 12, that will be 26 by 12, it will be 13 by 6. Okay, so the directrix equation going to be y equal to 13 by 6, which is a line parallel to x-axis. Next, finally, we want to answer axis. What is axis? Axis is going to be x equal to h. That means x equal to 3 by 2. So this is going to be the axis of the parabola, which is a line parallel to y-axis. Okay, fine. So we have a vertex and we got a focus, and this is the directrix, and this is the axis. Fine. Now let us answer this. So this equation we can write like, x equal to y square plus 4y plus 5. X equal to some quadratic expression of y. Okay. So that means this look like a x equal to ay square plus by plus c. Here a is positive. Okay. Here actually we have a equal to 1, b equal to 4 and c equal to 5. In the last video, I showed you that this x equal to ay square plus by plus c can be expressed like this. Y minus of minus b by 2a whole square equal to 4 times 1 by 4 mod a times x minus of 4ac minus b square by 4a. Okay, so first, what is minus b by 2a here? So b we got a 4, 2 times 1, it's going to be minus 2. Okay, next, what is this 4ac minus b square by 4a? 4, 1, 5, 4 times 1 times 5 minus 4 square by 4 times 1. It's going to be 20 minus 16 by 4. It's going to be 1. Okay. Next, what about this 1 by 4 mod a? That's going to be 1 by 4 times 1. That is 1 by 4. So now we can write this y minus of minus 2 whole square equal to 4 times 1 by 4 times x minus 1. Okay, this look like y minus k whole square equal to 4a times x minus h. So here h comma k going to be what? 1 comma minus 2 and a equal to 1 by 4. Now we can easily answer everything. Here the vertex we got. Vertex is what? H comma k, that is 1 comma minus 2, and focus is going to be what? So focus is going to be a plus h comma k, that will be 1 by 4 plus 1 comma minus 2, that will be 5 by 4 comma minus 2, that is the focus, and directrix equation going to be x minus h plus a equal to 0, that will be x minus 1 plus 1 by 4 equal to 0, that would be x minus 3 by 4 equal to 0, x equal to 3 by 4. Okay, this is the vertical line. Next, axis. What about axis? Let me write here. Axis equation is going to be y minus k equal to 0. Simply y equal to k. So that's going to be y minus of minus, it's going to be plus 2. Y plus 2 equal to 0. It is the horizontal line parallel to x-axis. Okay, fine. So we have this is the vertex, this is the focus, and we got a directrix equation x minus 3 by 2 equal to 0, and x is going to be y plus 2 equal to 0. Fine. Okay. Next problem. Find the equation of the parabola whose vertex is 3 comma minus 2 and focus is 3 comma 1. First let me locate this vertex and focus here. So this is a 3 comma minus 2 vertex, and here is a 3 comma 1, that is focus. Okay. Now the line passing through vertex and focus will be axis, right? So we know that this will be axis. What is this line? As you can see, it's the vertical line, x equal to 3. So for this parabola, axis is parallel to y-axis. Okay, so fine. So what is the vertex here? Our h comma k, we got 3 comma minus 2. Fine. And focus should be inside the parabola, right? So that's why this parabola should be upward, something like this. Okay, so this is how it will be. Now I can tell you the parabola equation will be in this form: x minus h whole square equal to 4a times y minus k. Okay, because this is the parabola whose axis parallel to y-axis and is open upward. Okay, so fine. Here we already know h comma k, that is 3 comma minus 2. All we need is this a. What is this a? A actually going to be distance between this focus and vertex. This distance is going to be a. So this is going to be 3. As you can see, distance between focus and vertex is going to be 3. That's what our small a. So this is going to be 3. So now we can write down equation of the parabola x minus h. H is going to be 3. X minus h whole square equal to 4 times a. A is this 3 and y minus of minus 2. So this is going to be x minus 3 whole square equal to 12 times y plus 4. Okay, this is the equation of the parabola. Fine. Okay. Next problem. Find the coordinates of the points on the parabola y square equal to 2x whose focal distance is 5 by 2. This is the standard equation of the parabola. If you compare with a y square equal to 4ax, then you will realize that a equal to 1 by 2. Okay, and we know that for a point p x1 y1 on the parabola y square equal to 4ax, focal distance is going to be equal to focal distance of point x1 y1 we have seen in the last video, that is x1 plus a. Okay, here, and that is given as 5 by 2. But what is a here? 1 by 2. So we should have x1 plus 1 by 2 should be equal to 5 by 2. That implies x1 equal to 2. Okay, first of all let me draw a rough graph here. So the focus is going to be, for this parabola, focus is going to be a comma 0, right? So that means 1 by 2 comma 0. So here is the, let's say, 1 by 2 comma 0 focus. Okay, now we are looking for a point P, that is x1 y1 whose focal distance from that point to focus should be equal to 5 by 2. Actually, there will be 2. If px1 y1 focal distance is 5 by 2, then its mirror image, let's call it p dash, which is going to be x1 comma minus y1. For that point also you will have a same focal distance 5 by 2, because this y square equal to 2x parabola is symmetric with respect to x-axis. Okay, you should be getting 2 points with a focal distance 5 by 2. Okay, first of all we got x1 equal to 2, right? Now we want to find out y coordinate. But what do we know here? X1, y1 is a point on the parabola, y square equal to 2x. So we should have y1 square equal to 2x1. Okay. Okay. Now if you plug in x1 equal to 2 here, we should be getting y1 square equal to 2 times 2. That implies y1 equal to plus or minus 2. So we have 2 points here, 2 comma 2 and 2 comma minus 2. Okay, these are the 2 points with focal distance 5 by 2. Okay. Okay, next problem. Find the equation of the parabola passing through the points minus 1 comma 2, 1 comma minus 1 and 2 comma 1 and having its axis parallel to x-axis. Okay, first of all, we know that equation of the parabola whose axis parallel to x-axis will be in this form: x equal to ay square plus by plus c, where this a, b, c are real numbers and of course a must be non-zero. Fine. Now we need to decide these 3 parameters a, b, c to decide the parabola. Okay, fine. What we know here? We know that this parabola, let me call it star, okay, pass through these 3 points minus 1, 2, 1 minus 1, 2 comma 1. By substituting these 3 points in the equation should give you 3 linear equations in 3 unknowns a, b, c, and hopefully we will be able to solve for them uniquely. Okay, so fine. First, this parabola x equal to ay square plus by plus c pass through the point minus 1, 2. That means, so this equation must satisfy this point. So if I substitute this point in the equation, we should have minus 1 equal to 4a plus 2b plus c. Let me call it 1. Again, this parabola x equal to ay square plus by plus c should also pass through the point 1 comma minus 1. Okay, so if I substitute this point in the equation, I should have 1 equal to a minus b plus c. Let me call it 2. Now, and this parabola should also pass through the third point, that is 2 comma 1. So when I substitute this point in the equation, it must satisfy. So we should have 2 equal to a plus b plus c. So let me call it 3. Okay. Now we have 3 linear equations in 3 unknowns a, b, c. So let us try to solve for a, b, c. Okay. Now I am going to use simply elimination method. Let me solve for a, b, c. Okay. Now what I do first, let me do 2 plus 3. Okay. If I do 2 plus 3, what I get? Equation 2 is a minus b plus c equal to 1, and equation 3 is a plus b plus c equal to 2. So I am adding these two. So here bb get cancelled. We have a 2a plus 2c equal to 3. So that should give you a plus c equal to 3 by 2. Okay, fine. Let me call it 4. And also let me do 1 plus 2 times 2. Okay. So first let me write the equation 1, that is 4a plus 2b plus c equal to minus 1. Now let me write 2 times equation 2, that's going to be 2a minus 2b plus 2c equal to 2. Okay. Now again, as we are adding, so these two get cancelled. So we have a 6a plus 3c equal to 1. Now that should give you 2a plus c equal to 1 by 3. Let me call it 5. Now let me do 4 minus 5. Okay, let me write the equation 4, a plus c equal to 3 by 2, and 5, that is 2a plus c equal to 1 by 3. I am subtracting, right? Okay, so the c get cancelled. So we have minus a equal to 3 by 2 minus 1 by 3. That should be 9 minus 2 by 6. So that is 7 by 6. So minus a equal to 7 by 6. That means a equal to minus 7 by 6. Okay, that is a. Now if I plug in, if I substitute a equal to minus 7 by 6 in, let us say, 4, what do you get? So minus 7 by 6 plus c equal to 3 by 2. That should give you c equal to 3 by 2 plus 7 by 6. That is 9 plus 7 by 6. That should be 16 by 6. That should be 8 by 3. So we got a c. Now let's plug a and c value in, let us say 3. So now substitute AC in 3. What do you get here? A value, we have a minus 7 by 6. So we don't know B. C value 8 by 3, that equal to 2. That implies the B equal to, we should be getting 2 minus of 8 by 3 minus 7 by 6. So that should be equal to 2 minus 16 minus 7, that is going to be 9. 9 by 6. 9 by 6 going to be 3 by 2. So it should be 1 by 2. So the B value we got 1 by 2. So we got everything now. Now we have A, B, C. So let me write down the equation of the parabola going to be x equal to A minus 7 by 6 y square plus 1 by 2 y plus 8 by 3. So this is the equation of the parabola passing through the points minus 1 comma 2, 1 comma minus 1 and 2 comma 1, and whose axis parallel to x axis. Fine. Okay. Okay, next problem. A double ordinate of the curve y square equal to 4ax is of length 8a. Then prove that the lines from vertex to its ends are at right angles. Okay. Here this y square equal to 4ax is standard equation of the parabola, which is open right side like this. Okay. Focus at a comma 0, vertex 0 comma 0. Now, fine. Now, what is the double ordinate? Double ordinate is a chord perpendicular to axis of the parabola, something like this, P dash. Let's say this meets axis at M. So let us say this is x comma 0. If this is x comma 0, then P coordinate must be x comma 2 root ax, as it is the point on the parabola y square equal to 4ax, and P dash must be mirror image of this P, so it must be x comma minus 2 root ax. Okay. Now let us say this is the double ordinate whose length is 8a. Okay, let's say this is the double ordinate with a length 8a. If the total double ordinate P dash is 8a, then this PM is going to be 4a. Of course, P dash M also going to be 4a. Okay, here the length of the double ordinate P dash equal to 8a, but in terms of x, the length of the P dash going to be what? 4 root ax. That means this 4 root ax must be equal to 8a. That implies root ax equal to 2a. If I take square both sides, then I will have ax equal to 4a square. Then we have x equal to 4a. Okay, so this x coordinate must be 4a. It's going to be 4a comma 0. So this am also going to be 4a. Okay, now if you consider the triangle PAM, okay, this is going to be isosceles triangle. So this angle must be 45 degrees. This also must be 45 degrees. So we have angle PAM equal to 45 degrees. Okay, fine. With a similar reasoning, if you consider the triangle P dash AM, okay, this is also going to be isosceles triangle. Okay, so therefore this angle also must be 45 degrees, as this is 45. Okay, so we have angle P dash AM equal to 45 degrees. So now the angle PAP dash is going to be what? Angle PAM plus angle P dash AM. This is 45 plus 45, that is going to be 90 degrees. So therefore the line from this vertex to ends of the double ordinate. What are the ends of the double ordinate? P is one end, P dash is another end. So this AP is perpendicular to AP dash. Okay, because we have angle PAP dash equal to 90 degrees. Fine. So we got this one 90 degrees. Okay, fine. Next question, sub question 1. If the coordinates of the ends of a focal chord of the parabola y square equal to 4ax are x1, y1, x2, y2, then prove that x1, x2 equal to a square, y1, y2 equal to minus 4a square. Sub question 2. For a focal chord PQ of the parabola y square equal to 4ax, if SP equal to L and SQ equal to L dash, then prove that 1 by L plus 1 by L dash equal to 1 by A. Okay. Let me draw this parabola, which is the standard equation of the parabola. So it is open right side like this. Okay. Here is the vertex, which is 0, 0. Okay. Here is the focus at A comma 0. Okay. Let us say this is the focal chord whose endpoints are P, x1, y1, Q, x2, y2. Okay. And we know any point on the parabola y square equal to 4ax will be in this form. At square comma 2at for some t belongs to R, because x equal to at square, y equal to 2at, parametric equation for the parabola y square equal to 4ax. So this point x1 y1 can be realized like this: at1 square comma 2at1 for some t1. This q can be realized like at2 square comma 2at2 for some t2. Obviously, here t1 is different from t2 as p not equal to q. Okay, fine. Now here PQ is focal chord. So the focus lying on this focal chord, right? That means here P, S, Q are collinear. That means we should have a slope of PS same as slope of QS. Okay, the slope of PS must be same as slope of QS, as PSQ are collinear. What is the slope of PS? It should be 2a t1 minus 0 by a t1 square minus a. And what is the slope of QS? 2a t2 minus 0 by a t2 square minus a. Okay, so next we can write this one: 2a square t1 times t2 square minus 1 equal to 2a square t2 times t1 square minus 1. As you can see, this 2a square cancel. Now we have t1 t2 square minus t1 equal to t2 t1 square minus t2. Okay, if I bring everything to one side, then I can write t1 t2 square minus t2 t1 square plus t2 minus t1 equal to 0. Then if I take t1 t2 common, then we can write t2 minus t1 plus t2 minus t1 equal to 0. Again, if I take t2 minus t1 common, then we have a t1 t2 plus 1 equal to 0. Okay, since we know this t1 is not equal to t2, so we must have t1 t2 plus 1 equal to 0. That means t1 t2 equal to minus 1. Okay, so we got t1 t2 equal to minus 1. Now let us look at x1 x2. What is x1 here? A t1 square. X2 is a t2 square. Okay, now this is going to be a square times t1 t2 whole square. Okay, so a square, what is t1 t2 we got? Minus 1. Minus 1 whole square, that's going to be a square. So we have x1 x2 equal to a square. Now y1 y2. What is y1? 2a t1 times what is y2? 2a t2. So it's going to be 4a square t1 t2. Now 4a square, but what is t1 t2? Minus 1. So we have y1 y2 equal to minus 4a square. Fine. Okay, so we are done with this. We proved that x1 x2 equal to a square and y1 y2 equal to minus 4a square. Okay, so we are done with the first one. Okay, now let us do the second one. Okay, here let us say SP equal to L and SQ equal to L dash. Okay. So what is L here? L is SP, distance from A comma 0 to 81 square 281. That's going to be under root 81 square minus A whole square plus 281 minus 0 whole square. Okay. So that's going to be under root. If I get A out, A T1 square minus 1 whole square plus 4 T1 square. Okay. A times under root. This T1 square minus 1 whole square plus 4 T1 square, we can write T1 square plus 1 whole square. Okay. So we can say that L equal to A times T1 square plus 1. Okay. Similarly, we can show L dash equal to A times T2 square plus 1. Okay. Now, so now we want to show 1 by L plus 1 by L dash equal to 1 by A. Let me start with a 1 by L plus 1 by L dash. So what is 1 by L? 1 by A T1 square plus 1 plus 1 by L dash is 1 by A T2 square plus 1. Okay. Now if you take a 1 by A out, then you will have 1 by T1 square plus 1 plus 1 by T2 square plus 1. Okay. Okay. Now if you cross multiply T2 square plus 1 plus T1 square plus 1 by T1 square T2 square plus T1 square plus T2 square plus 1. Okay. Now, what do you know about T1, T2? T1, T2 is minus 1, right? So, in the numerator, we got a T1 square plus T2 square plus 2. Okay. In the denominator here, T1, T2 whole square, which we can write minus 1 whole square plus T1 square plus T2 square plus 1. Now you see 1 by A. In the numerator we got T1 square plus T2 square plus 2. The denominator also same thing, we got T1 square plus T2 square plus 2. So these two get cancelled. So we have this equal to 1 by A. So 1 by L plus 1 by L dash equal to, we got 1 by A. Okay, fine. Okay, next problem. Q is the foot of the perpendicular from point P on the parabola y square equal to 8 times x minus 3 to its directrix. S is the focus of the parabola, and if triangle SPQ is an equilateral triangle, then find the length of side of the triangle. Okay. For me, this equation y square equal to 8 times x minus 3 look like y minus k whole square equal to 4a times x minus h. Okay. So if you compare with this, here h comma k role played by the point 3 comma 0, and a will be 2 because 4a equal to 8, so a must be 2. So this is the equation of the parabola whose axis parallel to x-axis and open right side. Okay. So let me state the focus is going to be a plus h comma k, but here k happen to be 0 and a is 2, h is 3. So 3 plus 2 going to be 5 comma 0. That is going to be the focus, and the vertex is obviously h comma k, that is 3 comma 0, and directrix equation directrix equation going to be what? X minus h plus a equal to 0, that is x minus 3 plus 2 equal to 0, that is x equal to 1 equation. Vertical line passing through 1 comma 0, and axis is y equal to k, but k is 0, right? So y equal to 0. That means axis is going to be x-axis only. Fine. So let me draw the parabola here. So let us say here is a 0, 0. So the vertex is going to be this one. This is the vertex 3 comma 0, and this is going to be focus 5 comma 0. Okay, and equation of the directrix is going to be this one, x equal to 1. Okay, now so this is a parabola open right side, so it looks something like this. Okay, this is a parabola. Now P is the point on the parabola and Q is the foot of the perpendicular of this P onto directrix. This is Q. P is the kind of a point on the parabola y square equal to 8 times x minus 3, so that we have a equilateral triangle. Okay, this triangle is going to be equilateral triangle. So we have a 60 degrees. Okay. So if this is 60, then this angle must be 30 degrees. Okay. So here we are to find length of the side of the triangle. Okay. Let's find out, this QS, because all sides have the same length, right? Equilateral triangle. So let us try to find out QS. Okay. So what we know here, if you focus on the triangle, let me call this point Z. Z coordinate is going to be 1 comma 0. Okay, fine. So let me focus on the triangle QZS. This is the right angle triangle. If you look at a sine 30 degrees, it's going to be opposite side, that is going to be ZS by hypotenuse, that is QS. We want QS, right? But do we know ZS? Yes. Okay. From 1 comma 0 to 5 comma 0, this length going to be 4. So sine 30 we have a 1 by 2, ZS we have a 4, and QS, okay, that implies the QS going to be 8. Okay, so therefore the length of side of the triangle equal to 8. Okay. Okay, next problem. The cable of a uniformly loaded suspension bridge hangs in the form of a parabola. The roadway, which is horizontal and 72 meters long, is supported by vertical wires attached to the cable, the longest being 30 meters and shortest being 6 meters. Find the length of the supporting wire attached to the roadway 18 meters from the middle. Okay, let's say this is the middle. Okay, the total roadway is 72 meter long. Okay, so this half is going to be 36. This half is going to be 36. Okay, now here the longest wire height is 30 meters. Okay, here also 30 meter, and the shortest being, this is the shortest, that is 6 meters. Okay, fine. Now for simplicity, as this cable hangs in the form of the parabola, let me assume the vertex of the parabola to be 0, 0. Let us say this is the origin. Okay, then equation of the parabola as it open up will be in this form: x square equal to 4ay. Okay, now let's decide this parabola first of all. So if this is 0, 0, and this is 6 meters. Okay, so this height is going to be 24 meters. Okay, now, so this is the point on the parabola whose coordinates are minus 36 comma 24, and this one is going to be the point with the coordinates 36 comma 24. Okay, now let's decide this a, x square equal to 4ay. That means we know the equation of the parabola up to a. To decide a, we make use of this point on the parabola, which is 36 comma 24. So here 36 comma 24, the point on the parabola x square equal to 4ay. If you substitute here, what you get, 36 square equal to 4a times 24. That means 4a equal to, you get 36 square by 24, which will be equal to 54. Feel free to verify this. 4a got 54. Okay, fine. So if this is 0, okay, and let us say here is a sum 18, we are interested in length of the wire attached here. Okay, let's say that is L. If this is total L, if this total is L, and this much going to be L minus 6. Okay, so this point is going to be what? 18 comma L minus 6, which is a point on the parabola again. Here, so here this 18 comma L minus 6 is a point on parabola x square equal to 54y. Okay, so since it is a point on the parabola, it must satisfy when we plug it. So let's plug it here. 18 square equal to 54 times L minus 6. Okay, so L minus 6 equal to 18 square. I can write 18 times 18, 54. Okay, so 18 times 18, 54 I can write 3 times 18. So this 18 cancel. So this 3 and this 1, you got 6. So L minus 6 equal to 6. That implies L equal to 12. So what we got here, this length L is going to be 12. Okay, because L minus 6 equal to, we got 6. So L is going to be 12. So therefore, length of supporting wire attached to the roadway 18 meters from middle equal to 12. Okay, let me stop now. Thank you.